Good morning, students. In our today's class, we are going to discuss about problem number 18. In this problem, the displacement of a particle is zero. The displacement of a particle is zero. This is for this problem only for star and F1. The next problem will be for remaining sections also. Look, the displacement of a particle is zero at t is equal to zero. Okay, and it is x at t is equal to t seconds. This means it travels x displacement in t seconds. It travels x displacement in t seconds. When it starts its journey, the time t is equal to 0. After some time t, it travels a displacement x, moving with the position in x direction, with a velocity which varies as v is equal to k into root x. That object which is moving along x-axis up to certain distance in time t with the velocity v is equal to k root x, k into root x, k into root x. This is given. And what he is asking, the relation between v and t is, observe here in this equation, the relation is in terms of velocity and x displacement, in terms of velocity and displacement. In this, no time included. Now we need to find the relation in which velocity and time must present. Velocity and time must present. For that we'll go for integration method. V is equal to k into root x, that is equal to, what is v? We all know that velocity is equal to displacement with respect to time. That can be written like this: dx by dt, differentiation of displacement with respect to time, dx by dt is equal to k root x. Instead of writing v, what we are writing here? dx by dt. Now come on to the simplification. Just we need to change this or convert this into integral form. Come on, dx by dt is equal to k into root x. Bring this dt on right hand side. Then what will you get? Dx is equal to k root x into dt. Dx is equal to k root x into dt. Bring this dt on this side. The same equation. Now dx is equal to k into root x into dt. K into root x into dt. Now bring these x terms on one side and constants on another side. Dx by root x. Look, this is the x term. Bring this on left hand side. Dx by root x is equal to k into dt. K into dt. So dx. What is the value of x? X is equal to, root x is equal to x to the power of 1 by 2. What is the value of root x? Root means whole to the power of 1 by 2. That I can write like this: root x is equal to x to the power of 1 by 2. Bring this to the numerator. Now it is in denominator. Bring this to the numerator. Then what will happen? In our previous mathematics class, we discussed this so far about exponents and powers. Here, bring this x to the power of 1 by 2 into numerator. What will you get? X to the power of minus 1 by 2. Our formula will be like this. Maybe like this: x power n is equal to 1 by x to the power of minus n, or 1 by x to the power of minus n is equal to x to the power of n. According to that formula, from exponents and powers, we can write like this: x to the power of 1 by 2, which is in denominator, you can bring it into numerator by changing its sign of the power. That is, x to the power of minus 1 by 2 into dx is equal to k dt. Okay, k dt. Now, here the differential functions are there. You can easily integrate this. Note it down. This one, note it down. We'll go for this one now. Observe. Now integrating on both sides. Previous equation, integration on both sides. So integral x to the power of minus 1 by 2 into dx is equal to k into dt. Integral here in your problem, he given that it traversed from 0 seconds to t seconds. It traversed or it travel for 0 from 0 seconds to t seconds. That's why I written here limits for the integration from 0 seconds to t seconds. Integral of x to the power of minus 1 by 2 dx is equal to k into integral of 0 to t into dt. Now, our integral equation formula, the basic formula in integration, x to the power of integral of x to the power of n into dx is equal to x to the power of n plus 1 by n plus 1. X to the power of n plus 1 by n plus 1. I will write like this. X to the power of n, integral x to the power of n dx is equal to x to the power of n plus 1 by n plus 1. So this is your formula from integration. Formula from integration. Look. Integral of x to the power of n dx is equal to x to the power of n plus 1 by n plus 1. Power should be added to 1 and by divided by the same one, n plus 1. Integral over x to the power of n dx is equal to x to the power of n plus 1 by n plus 1. This is your formula. According to this only we are going to do this integral. Okay, come on to the second one. Got it? X to the power of n. What is the value of n here? N is equal to minus 1 by 2 into dx is equal to k into integral over 0 to t into dt. Come on, what we are going to do here? By removing this integral and the differential function, both are inverse functions. By removing this, you will get like this. X to the power of minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. Minus 1 by 2 plus 1. That is equal to k is a constant. You can't integral this. Okay, here 1 is there, 1. It means nothing is there. That is, if nothing is there here, you all know that t power 0 is present. What is the value of 1 here? T power 0. If nothing is there in between integral and differential function, you can write like that. That is t power 0 is equal to 1. Here. Or integral and differential function will be cancelled, then t is equal to, t will be remain like this. Even you are taking t power 0 here, t power 0 plus 1 by 0 plus 1, t power 0 plus 1 by 0 plus 1, then you will get a t only. Once again you will get a t only. So that t and lower limit and upper limit. Come on to the next step here. Minus 1 by 2 plus 1. So you need to subtract minus 1 by 2 from 1. Again you will get a 1 by 2 only. Again you will get a 1 by 2. So x to the power of 1 by 2 divided by minus 1 by 2 plus 1, 1 by 2 only. That is equal to k into, here how to proceed? Substitute the upper limit minus lower limit. Substitute the upper limit minus lower limit. What is your upper limit? T. Substitute t first minus lower limit 0. And now this 1 by 2 will become as a 2 by 1 and x to the power of 1 by 2 become root x. What will happen to the 1 by 2? 1 by 2 in denominator 1 by 2 is there. Now that will become as a 2 and x to the power of 1 by 2 can be written as root x. Root x. Come on to the next step. Note it down. Got it? Come on to the last step. 2 into root x is equal to kt and bring this 2 on right hand side. Root x is equal to kt by 2. Kt by 2. Now from the given, what is given here? In our first problem given v is equal to k into root x. Now what we got here is from these calculations and the simplifications, what we got? We got the value of root x. We got the value of root x in terms of t. root x in terms of t. What we got from these previous calculations? Root x in terms of t. We got a relation between displacement and time. Substitute this in given equation. V is equal to k root x. Instead of writing root x, you can write kt by 2. Look, V is equal to k. Instead of writing root x, we are writing kt by 2. kt by 2. Now what will you get? V is equal to k into k square t by 2. Observe here, in this equation, you got velocity and time. This is what he is asking. A relation between velocity and time he is asking. Relation between velocity and time he is asking. We got this. Okay. Everyone note it down. We'll go for next sum. The whole sum you can watch here. Okay, take a screenshot and do it. Now, problem number 19. This is for all sections. An automobile traveling with a speed of 60 km per hour can brake to stop with a distance of 20 meters. With a distance of 20 meters. If the car is going twice as fast, that is 120 km per hour, the stopping distance will be. What he given? He given that velocity v1 is equal to 60 kmph, kilometer per hour. No need to convert into meters per second, because it is going to be cancelled. And he is telling that the velocity is doubled or twice. That is v2 is equal to 120 kmph. While it stops with this velocity, it covers a distance or displacement of 20 meters. In the same time interval, if its velocity is doubled, how much distance it covered? This is your question. A automobile is traveling with a velocity of 60 km per hour and travels a distance of s is equal to 20 meters. If its velocity is doubled, how much distance that it covered? This is what he is asking. So here you all know the relation between displacement and velocity. In general, everyone will write like this. Displacement is directly proportional to velocity. Here it won't work out. So how to proceed? Look, here they are decelerates with the same deceleration. So your equation must contain acceleration. So you can go for this one. S is equal to half at square. Or S is equal to ut. Look, I'm going to solve this one with this one. S is equal to u. T is equal to, what is the T? T is equal to again velocity by acceleration. So here what will you get? S proportional to u square implies S1 by S2 is equal to u1 square by u2 square. S1 by S2 is equal to u1 square by u2 square. Can you do this? Easily you can do. Substitute the value of S1. How much it is? 20 by S2 is equal to u1 square 60 into 60, u2 square 120 into 120. So a simple calculation. You can proceed to this. So I am going to write this answer. You can proceed. You all know rest. Just cancel this. 61s, 62s, 61s, 62s. You will get 4. Like this. 20 by S2 is equal to 61, 62, 61, 62s. You will get 1 by 4. Just cross multiply. 20 into 4 is equal to S2 into 1. 20 into 4 is equal to S2. That is, S2 is equal to 80 meters. This much distance they will cover. Note it down. Okay, noted.